I'll try to finish first CPP 13 and then go to CPE 14 and 15 today. So there are 3 CPP I try to get covered. So let me go back to CPP 13. Wait a minute, not this one. It must be here. All right. So we learned about a few things about this basic syntax about exception, such as catch. Sorry, the first one is try, and then throw and catch. Those 3 keywords, and this enabled us to design a code such that we will be able to handle unexpected situation in a different way. Then you have to worry about the whole thing yourself, but then we try to design this separation between the try block and the catch block such that we kind of have a piece of code that will handle exception this way. Okay. What's very important, there's a few things I would like to make sure you understand, which is probably going to appear in the final, the last midterm. But I'm going to go for this one here. Message. Sorry, I want to go to the exception, which is, where's my code? Oh, I know where I'm going. So, so in terms of exception, there is a few things I want you to learn, which some of you probably get it, but I want to make sure this important lesson will get through all of us. So the first thing is a separation, the concept of separation between the detection of a condition and the handling of that condition. Okay, what's the difference between these two? One is you want to detect there is a bad memory allocation. You want to detect there is a unexpected input that to your system, or you want to detect there is a JSON that's the syntax is incorrect that you cannot process, or you want to you might detect, say, inside this JSON, this is supposed to represent the GPS location, which is the GPS DB object, but it doesn't have latitude and longitude. So you have this condition, which essentially, if you think about 50% or even 70% of the code is trying to checking certain condition, whether that condition is there or not. Okay, and the thing is that there are actually 2 parts of that. One part is the condition itself. I want to detect that there is something which is wrong in your code as a programmer. But there's the other part is that what's the follow-up to that detected condition, which is, I call it the second part, is the handling of that condition. And the thing is that this essentially what we learned about exception, try to explicitly split this 2 issue by 2 different pieces of code. So the detection must be somewhere within the try block, where the handling of the code will go to the clause, the catch clause, and multiple of them, depending on what kind of. So that is the first issue I want to make sure what we're trying to do here is this separation. Okay, and why is this separation useful? Then I want to go to the second piece. You're either dealing with a large piece of software, or that this piece of software, and or, it should be and or, this piece of software was developed by multiple people, multiple programmers. Okay, so let's start to differentiate you're learning about programming by yourself, then programming as a team. And it is actually quite important concept for us to learn ecs36b, because it could be somebody write the code to handle the first element of that separation, basically just doing a detection. And that particular person might not, and in many cases should not, determine what is the best way to handle that condition. So therefore, when you are integrating your code with somebody else's code, and the detection mechanism about memory allocation error or missing a particular attribute, such as a latitude and longitude, those kind of condition is being detected by one programmer, but then there is another programmer need to worry about, well, how do I present this information to the user of the program? And therefore, they will try to think about, depending on the semantic of the application, especially if you integrate this with inheritance. So you will see that the typical detection of those conditions typically happen at the base class, or actually pushing toward the base class. While other programmers, when they're using your base class or first 3 level of the derived class, they will continue to derive to develop more class, but using the exception you already developed. And therefore, because you know nothing about the new derived class, as a person who provides this detection part about the separation, and therefore is sometimes not optimal for you to really develop the handling. So essentially, this separation is not just about a different way of representing the information. It's really thinking about a whole software development cycle that, because you have inheritance, that you will continue to extend your functionality for different purpose. Of course, virtual function help in that process. But more importantly is that typically the person who write the code for that first separation should not mandate and should not determine how that should be handled. Okay, for example, when we have the detection of the condition when the memory allocation is bad. And why memory allocation is bad? Because you actually asking for a huge amount of array of integer. That's the example we use, and that will trigger exceptional standard exception for bad alloc. Well, then we talk about the second part of the separation is how to handle that. The default way of handle that is just say, hey, your program crashed, okay? Or crash or stop or whatever. You want to display a message saying that, hey, you sucks. You actually had an unbelievable big number, and therefore I protest. My software will say, hey, you shouldn't do that, and then crash. And then the customer feel very upset, and the programmer got fired. Pretty much like that. Okay, what do you think a better way to handle this? A better way to handle this is, okay, fine. You want to allocate such a huge array, but the other option is that, well, I don't have that much memory, but I try to allocate as much as I can. Okay, you ask for 10 billion. I cannot give you 10 billion, but I can actually let the program run with probably 10 million, at least for now, before it crash. Okay, so now this is a trade-off. Whether you think the application developer think that that might be a better way to handle that, so which means that I will give you 10 million first. You can run for an hour, but then eventually you will still run out of the memory if you really need 10 billion. But that time, I'm going to give a warning when you reach 5 million to say, hey, we're going to going out of business pretty soon. You better worry about how you can handle that. So you kind of have a more graceful way of handling an error, but depending on the application semantics. Okay, so that's kind of the things I want you to know, that why it's important for you to understand the idea of this try, throw, and catch, because they really separate different needs about the software, different piece of software, different component over there. Okay. So I want to ask you a question then. This is related to this. We kind of say catch, okay? Catch, some kind of throw. Let me ask you, is there anything not being able to, not catchable, I should say, not catchable? Okay, so you think about, so we say, well, memory allocation, you can actually catch. Let me actually show you this slide, because we talk about the standard. This is the standard, means STD is going to catch. What kind of runtime error do you think that this particular diagram hasn't covered yet? So we have an allocation, we have a casting with type ID, exception, failure, runtime error, some kind of overflow, range error, underflow, whatever. Okay, we have a bunch of things. What kind of things? No matter how you write the catch clause, no matter how you put the try, it won't work. Yeah, in the back. Okay, all right. Okay, that's a very good point. If I want to access a restricted memory, by the way, you're right. What's the name again? Aaron, right? Okay. Aaron basically mentioned that if you try to access some kind of prohibited area of memory, you cannot, because over here it didn't say anything about segmentation fault and whatever violation. Okay. So essentially, if you have a certain kind of error that's touching the prohibited issue or privilege about the operating system, the runtime environment, this is go beyond the language, and therefore the language won't be able to handle that. So that's a mistake that we potentially make. Let me show you an example. I actually have this example here, but I want to just run it. I have a program called segfault test. Let's take a look at segfault test. Okay, so if you take a look at the segfault test, I have a P is a pointer, is an address, and I set the address to be 256. Remember, I said the first page of the memory is always unusable. So as a C programmer or C++ programmer, you should remember that it's not just the reference 0 is a segmentation fault. Dereference anything between the first memory page, if your page is 1K page, means that the memory from 0 to 1023, 2 to the 10 minus 1, assuming your 1K page. Any of this address is prohibited. If you hit any of the address, you're going to get a segmentation fault. That's why I actually put 256. By the way, I believe I can put 1023. I can still got a what do you call that, segmentation fault. So take a look at this code. What I did here is I tried to print the star P. Star P, I tried to dereference an address, which I think is prohibited. And I tried to do that. And then I put in the try clause. And I say, hey, this is I tried to see if I can catch from the standard deviation. Okay, write the code looks like this. Okay, so let's try to compile this code. Okay, let's try a.out. You can see I got a segmentation fault. All right, because I'm accessing within the first page. And the first thing is I got a segmentation fault. The second thing is I was not triggering the exception I put it in. So this is not an STD exception if you remember the code I showed you earlier. Okay, so that's essentially this try clause doesn't help you to do print I am here, whatever. Okay. Any question about this? So there are some conditions. I just want to tell you there are some conditions which the exceptional handling won't be able to help you to catch. And when you're taking ECS 150 or ECS 50, you probably learn more about what other condition, and you will learn the concept called the difference between what we call software trap, hardware trap, and interrupt. And then what's the difference between those? None of those should be able to catch by the catch and exceptional handling. Okay. All right. Are you good? Okay. If let me actually be a bit evil today. Okay. So assuming I develop a piece of software, 5 million lines of code, and I know my program somewhere, sometime, will have segmentation fault. Okay, by the way, a lot of senior programmers, they will deal with this situation from time to time. So you have a piece of code that you know somewhere you have a segmentation fault. You have a memory leak, you have something which is not persistently show up. It's occasionally show up on certain input, and I don't know why. And then guess what? I have a demo to my big boss tomorrow. And this will be bad, right? If I go into the demo room and it just happened. By the way, it always happens. When you have a really big demo, the worst nightmare always show up at that time. Okay, based on my experience, that always happens. Okay, so how will you dodge the bullet? Just as a programmer that you know you have a segmentation fault, you don't know where it is. You don't have time to debug, or you don't have intention to debug. How do you deal with this? I mean, exceptional handling probably cannot help. Yeah. Okay, yeah, that's a great idea. I like that. Yeah. Yeah, some suggestion. Okay, I remember one time I had that issue that, okay, this part I probably shouldn't even record it because it was before they have a segmentation core. Usually your group core up. Have you heard about why May5 has a core? Because it's dumping all the memory. I mean, this program is small, so it's very fast. You don't see that, but it's actually dumping the core. So one of the ideas that we had was having two windows a little bit overlaid with each other. And the thing is that when I'm seeing the program is actually isn't responding, okay, I know it's core down. Not actually me, my office mate did that, okay? And what he did is he moved the mouse and clicked the other window to cover the segmentation fault message, and then continue to rerun another instance of the program. Okay, just this is practical, it's evil, okay, that's fine. All right, so I'm going to tell you a more technical solution to deal with that. Okay, overlay this window. Sometimes you need a really good skill. So I'm going to teach you how to catch segmentation fault. So you have an exception, but I want to have other way to catch something exceptional handling cannot catch. So I want to show you this program called segfault test 2, which is under CPP 13. Sorry. Yes. Okay, so the architecture is the same. We have that separation. Guess what? We have a separation. One separation is called detection of the condition. And the other part, the separation, the second component is try to process that. So let me just tell you that you have to include this line called signal, because whenever you have a segmentation fault, it's really internally is something called a signal. It's not exception. So exception is a programming language concept. A signal is really an operating system concept. So I'm reapply the concept I just talked about now to the signal level, which is the system level. So you have to include that called signal.h. Right? In fact, it's very simple for you to do that. So now I actually write the handler. Okay, this handler is called segfault, sig action. Okay, it's a function, has certain function signature, has to follow certain function signature. It's called it's return void, and then it take a signal number, take another data structure called sig_info underscore t, and then there is another one is a pointer, is a generic pointer. Okay, you have 1, 2, 3, three thing looks like here, and inside here I just basically say, hey, I print something, but you can do anything you want within this function. I'm just showing you something fairly simple. But let's take a look at this. Let me change this to 1023. Okay, I'm changing that. Is still the same program that foo is a pointer, and the pointer value is 1024. However, for me to set up this catching mechanism, now I have to do a little bit more work. So I have to create a data structure called sig action. Okay, this is all related to the system call that's provided by any Unix operating system. They all have this. So I basically create a data structure, and this view line, I'm just setting up this data structure. But one of the things is important is that I actually set up one parameter called sig action. So inside signal handling, we actually call the handler is called signal action, meaning that when you catch this particular signal, it will actually send it to that particular action. And what is that action? Is a function pointer, which is the topic we're going to talk about. You see that you probably never saw me doing this, meaning that you have an assignment. On the right-hand side of an assignment is a function name. This is a sig action. You see that? I just basically define over here. So whenever we use a function name, the function name itself is actually a pointer to the function, which is what we're going to talk about in CPP 15. And so by setting up this way, I kind of set up the preparation for setting up to catch that particular signal. And then what I do is now I call this is system call called sig action. By the way, if you do a man on any Unix computer, you say sig action. It will tell you that this one is a system call. You see that? That's a system call manual. There is a function called sig action software signal facility, and then has a lot of data structure. Basically, you will see that. That's why I have a SA handler, sig action, and those kind of parameter I'm using. But this, hopefully, this simple program will give you some good idea about how to write the code. All right, so now you can see that finally I call the sig action. The sig action took 3 parameters. I typically only use the first 2. The first parameter basically say what kind of signal you want the SA data structure to catch. So essentially, this is a SIG SEGV, which is a segmentation fault. Okay, SEGV is the signal that will generate when you have a segmentation fault. And then you set up this SIG action SA, you just put the reference to the SA or the pointer to the SA and set up this call. So after you set up this call, you just try to dereference this foo. Okay, so the thing is that if I don't have this line, if I don't set it up, okay, let's try to compile this code. If I don't set this up, and I'm expecting to still get a segmentation fault. Okay, I'm still have a segmentation fault. But when I make that call, okay, if I do this, now let me recompile the code, and I run it. Now I'm actually caught that. Okay, that was the printout that I actually realized that you try to access the memory address of 3FF. By the way, 3FF, I don't know why it is, but whatever address it was, that is something which is being caught by the SIG action. Okay, the calling. Okay, let me go back to the code to make sure you understand what we're doing. So this, this piece of code just shows you that for those error condition that cannot be caught by exceptional handling, there's another way you can do it. Depending on what kind of signal the operating system is going to generate, then you basically set up saying that, hey, I want to redirect the default handling function to whatever function I want that to do. So go back to that example, kind of evil example I told you earlier. Essentially, if you have a piece of code that you know is going to generate some segmentation fault, and you don't know where that is. So you might want to do is just like this piece of program to set the SIG action to catch any segmentation fault. And then in that process, that you try to gracefully exit the program, basically just be honest, saying that, hey, we have an internal error, so we have to do something. So just give everybody 5 minutes to basically save the data, and then you crash. And also in the segfault, you might be able to realize some of the information about what kind of address that's being accessed and what kind of information. And that information might help you to realize more about where that potential segfault is. Okay. So I'm giving you this code as well. So you can see that this directory or CPP13, it gives you a bunch of code such as fetLLOC, try to do the traditional catch, and then also the segfault test stuff for you to be able to do something which is go beyond the exceptional handling. All right. Any question? Yeah. I thought it is, but it's not, right? Because 3FF is not 1023. Is that right? What is 1023 in hexadecimal? 1024 should be 2 to the 10. Oh yeah, you're right. 3FF is yeah, it's probably, yeah, that's I think that's true. Yeah, 3FF. Sorry, my hexadecimal conversion is a bit rusty. Yeah. Okay, thank you. So it actually print out the address. So if I want to debug, I just go through every single address I'm going to access to see where's the code it tried to access 3FF, right? I can do that before I access any address. That might help you to determine where that is to do this kind of data flow debugging. Okay. All right, good. By the way, segmentation fault is a hard challenge for C programmer or C++ programmer, especially you have something we call a memory leak. In language like a Java or Python, your memory allocation was protected by the runtime support. So you won't have something called memory leak. But as a C programmer, C++ programmer as well, you have this malloc and free. That's you actually control those actions. And also you have now C++, you have a new and delete. And such that you basically manage memory yourself. If you forgot to match correctly, then you're going to accumulate unusable memory for a while. Because sometimes if you develop a server, the server is going to run for years. And therefore, eventually you run out of memory and then some kind of bad things happen. Okay. All right, so the other program that we show you is the mobility send. So we actually went through this code last time, but now I want to show you that the purpose of this code is such that I will be able to having exceptional handling, not just in a single program, but I want to do it across multiple programs, just like the idea of JSON RPC. So remote procedure call is, I want to think about this. What is a remote procedure call? I have one function on this machine. I'm actually calling the other function on the other side of the internet. That's called remote procedure call. Well, think about this. Now we understand the concept of exceptional handling. What happened if the throw statement was actually over there? So you have two functions. Function A calls function B. And then, however, function B is not running on this machine. It's actually running on a different machine over there. And that function detects the condition, and they throw an exception. And the thing is that, well, that exception will not be able to just naively propagate all the way over here, because the exceptional handling basically is only work within the same executable. So when you have a distributed program, then your exceptional handling semantics essentially broken. Okay, so we try to mediate that problem. And that's why over here we have this condition. We try to encode the information about exceptional handling and such that it will be included in the response I receive from function B. If function B indeed generate exception, then that exception information is encoded in the response, which is also in JSON. And over here at the first original caller side, then I will just basically extract that and then throw the right. That's why we actually have this. We say, well, if your exceptional status is a failed, oh, sorry, not this one. I should actually look at here. Okay, if the status is a fail, then you essentially throw the ecs36b exception. So you kind of throw it twice. The first time it will throw at the function B, which is the remote server. However, that is not really being propagated to the client. So the server encodes that information as a JSON over to the client. And the client basically reinterpret that response and realize that is an exception, and then they will generate this exception. So in this way, now you can have the exceptional handling across the client and server and work seamlessly. Okay, not quite seamlessly, because now if you look at this, this program called mobility send, the mobility send, basically now the mobility send need to do more code, right? It used to be I just call a function. Now I have to do a lot of this checking on the client side, and which then makes the exception not so transparent. Okay, so now that's actually the solution. I just want to show you very quickly. is actually CPP 14. So CPP, if you think CPP 13 is equivalent to CPP 08, what is CPP 08? It's a remote object. What is a CPP 09? It's a proxy object. So now I'm going to show you a proxy object implementation of the remote. That's actually happened in CPP 14. It's exception object. Okay, so first I want to take a look at the new version of the mobility send. If you take a look at mobility send, it's still try. Okay, this part is essentially the same, and the catch clause is exactly the same. But the inside is just spn.send. It's one line without doing anything. And what is the SPN? Is a shadow message. So essentially, I have a shadow version of the message to include the processing of the exception within that shadow. So what did I do? Nothing magic. It's just moving the code into the shadow, because what is a shadow? It's really a proxy. It's really trying to hide all the complexity between the communication between client and server, and such that I build that proxy so the real client program need not to worry about those details. So if you look at the shadow message, CPP, if you take a look at shadow message.cpp in the send, you can see that this is a typical remote procedure call, shadow object stuff. But then inside here, I actually did all the check, like what I did in the CPP 13. But I kind of put that logic, exactly the same logic, into the implementation of the shadow, and such that I basically just throw. Yeah. So this has a really good benefit for the programmer for mobility send, because now I don't need to worry about whether this particular object is a remote or local. Because you see that the point is, when we deal with the difference between CPP 08 and CPP 09, is that CPP 09, I don't need to worry about whether that is a remote object or local object. I just call that particular object and will handle the rest for me. And the same thing here is that when I receive an exception, I don't need to worry about whether this exception is coming from local or from remote. And that difference is all being hidden within the shadow. Okay, so that has been already included in the CPP 14, and you can compare when you study exceptional handling. Also try to compare CPP 13 and CPP 14. See exactly what's the difference to actually make the communication different. Okay. All right, I'm going to jump to the next topic, which is probably the last, I would say, the introduction to the language, which I think is every C++ programmer need to know. Okay, this is about template. Okay, so there are three kinds of template I'm going to talk about. One is called function template, one is called class templates, and the other one is standard template library, which is we have already been using std vector or std map, std string, those kind of things. So we will be cover the three. Make sure you know what template, how to write a function template, how to do a class template. Then you can actually develop the code more effectively. Okay, so first let's talk about function template. Okay, the code will be in CPP 15. Right? So what is a function template? So assuming you have these two functions in the orange and in the yellow, if you take a look at these two functions, they're kind of different, but they're kind of similar in terms of their structure. So they're both doing some kind of comparison between two numbers, and just very simple example. On the other hand, they're handling different type of object. So the orange is handling the comparison between this two number and then return the smaller number for integer. But while the yellow is actually comparing two double. By the way, you can actually compare two things or two GPS location or two person, whatever you want to do. And the thing is that we actually see this kind of similar structure, and the only difference is the type of the argument and the type of the some of the return type you need to worry about. So therefore, this is called a template in the green. So essentially, this template can be the generalized version of the green and the yellow. So essentially, I define a template and such that the type of the argument or the return type is parameterized. And then I basically, instead of defining each of the function individually, I create one template and I use this template to create the whatever function I would like to have with the appropriate type. Okay, so let me show you an example how do I get it to work. If you think about what is a template looks like this. It has a keyword template, and then it provides within this pair of smaller than and greater than sign that you can put one or more types. That's actually going to be used in the following what we call the template construction. Okay, so in this case, I only need one type. I call a type name T. So type name, this could be the T is going to be replaced by this particular variable. So you have the capital T here. This is a function name, is minima, and then the type of the A variable is T, B variable is also T, and then you can return whatever you want. So essentially, you can just define the type. You can see that everything else is the same except the type. Okay, so that's how. So let's try to see some example in CPP 15. Okay, I'm going to show you only first one, and then okay, so I have a template that this template is called is in range. Okay, is in range. So let me actually use a different program to do that, because this one is okay. I'm going to use fptrle.cpp instead. This one, I have a template, which is not being commented out. So you can see I define a template. And inside this template, I have a two type instead of one type. Okay, as I said, you can have multiple of this. So I can define a template with type name T and type name F. And then the function is essentially bool is in range, which is the two different variable with T and F respectively. And I haven't actually talked about how to do the lambda, but don't worry about this right now. But here you can see I can just with this I can just call it. I said is in range. I just call that function, and because I already defined the template, so I basically just put in whatever, because the first number is what 35.0 is a double, and therefore it will actually trigger this template and execute this part. Yeah. Yeah, type name is a keyword. Type name is a keyword. Hold on 1 second. Let me see. I want to see another example. Let me actually go back to the previous example, FLE. It's probably better. Okay, in this example, this is a template, and this is actually a working template. I don't know why I comment that out. I must have done something interesting. Okay, so in this, I define, when I create this function, you can see that I have 3 arguments. One argument is the type name, but I also provide some value. So by the way, it's not only provide type, but I can also provide some kind of range. So if you interpret this part, this is equivalent to compile a function such that I provide a range. That's if the value that you input for this function is in range, is in between the upper and the lower, then you basically have this. Okay, so I'm sorry, my time is up. I'm already over 2 minutes, but let's continue this on Friday. Okay, by the way, I will announce about what's going on on Friday. But we'll try to finish CPP 15 on Friday.